Hi, everyone. Welcome to today's joint webinar, State Action and New Technology for Data Center and Large Load Flexibility, held by the NASEO Powering Up Data Center Series and the NASEO-NARUC Grid Interactive Efficient Buildings Working Group. My name is Camille Norton, and I serve as the Program Coordinator on the National Association of State Energy Officials Electricity Program. For those of you unfamiliar with NASEO, NASEO is a national nonprofit that supports all 56 state and territory energy offices throughout the U.S. NASEO serves as a resource for and about state energy offices on a wide spectrum of energy topics and through a variety of means. One of the ways we do this is through events such as this one, hosting national dialogues on emerging energy issues such as the one today. I will go ahead and give a brief rundown on NASEO's Powering Up Data Centers webinar series. This is the 7th webinar in the series, and the series explores and has explored specific strategies state and territory energy offices can use to address growing data center electricity demand while supporting energy affordability and grid reliability. Recordings of all previous Powering Up Data Centers webinars are available on our website if you've missed them. And as we continue on in this series, we welcome your input on different topic ideas. But before I go ahead and run into the housekeeping reminders, I'll pass things off to Jeff Loiter from NARUC to go ahead and introduce NARUC and maybe speak a little bit to the Grid Interactive Efficient Buildings Working Group.
Thanks, Camille. Appreciate that. Yes, Jeff Loiter. I'm a technical director at NARUC's Center for Partnerships and Innovation, or CPI. NARUC is a member organization like NASEO. We serve the nation's public utility commissioners in all states and territories. If you're not familiar with CPI, we are the technical assistance group within NARUC and provide our commissioners and staff with resources much like NASEO does for their members with webinars and trainings and other written materials. We're funded by cooperative agreements with DOE, and so we're thankful to the Grid Deployment Office for supporting this work, and also the work that we've done on the Grid Interactive Efficient Buildings Working Group. Rod Sobin is on, and he's really the dean of that group, but this joint project focuses on how buildings and as energy consumers can contribute to the grid through flexibility and efficiency. I just want to say a bit though about the large load work, because that's an area that's very, very high priority for our members, as I know it is for NASEO members. And this has been an area that we've focused on a lot. And I want to point people to the demand roundtables that we've done at our past couple of conferences, and that we'll be doing again in Seattle in a couple of weeks, which brings together commissioners, utilities, and large customers to talk about the issues. I will put a link to our load group webpage in the chat here in a minute, and I encourage you to go look at that to get some additional perspective on this important issue. Thanks, Camille.
Thanks, Jeff. And Jasmine, if you go a couple slides down, I'll go over the housekeeping reminders. So this is a Zoom webinar format. Only speakers and panelists will have camera and mic access. But please note that following the presentations and moderated discussion, we will have the opportunity for audience Q&A. So please use that Q&A function to pose your questions. And also note that this webinar is being recorded and will be posted to our website. And now for a brief agenda overview before we get started. So first, we will hear from our moderator, Andrew McAllister, commissioner from the California Energy Commission, who will provide opening remarks, as well as share the perspective from California on data centers, large loads, and tools needed to help inform states to plan for associated demand growth. Then we will hear from Kim Van Winkle, an attorney with the Public Utility Commission of Texas, who will provide an overview of Texas Senate Bill 6. And following Kim, we will hear from Jeff Bladen and Ben Wheeler of Veris, who will discuss the work being done at Veris. So with that, I will go ahead and pass things off to you, Andrew.
Well, thank you, Camille. Really appreciate it. And thanks to our presenters, Kim and Jeff. Really appreciate your joining us. And as I think everyone should have gathered by now, this is a team effort of a lot of different discussions in the NARUC context and the NASEO context. I've been involved with leadership at NASEO for many years now, and really just appreciate both NASEO's convening ability and I think highly attuned understanding of the state's needs in the Energy Office context, and its ability to tease out thematic interests of subsets of states and emerging issues such as this one that are really worth talking about and getting ahead of if possible, and really understanding in a deep way. And likewise, NARUC provides such value to its PUC and PSC membership. And I think the coordination and collaboration between NASEO and NARUC is really multiplicative in a very positive way, helping us all as policymakers and policy implementers at the state level understand the common challenges we face and really look for solutions. And so just at all levels, this is a great collaboration. So I just wanted to make sure to point out just how powerful these conversations are, and thank NASEO and NARUC staff for really keeping everything moving. So my name is Andrew McAllister. I'm one of 5 commissioners at the California Energy Commission. I oversee most things demand side, buildings and standards and codes and the like. And I'm leading a lot of our data work, which I think is relevant, somewhat relevant in this context, and a number of other areas. But market integration, working on that in the Western Interconnection, and the like. So a lot of relevance of these large load conversation and the data center conversation in my world. I did want to make just a few comments about the nature of data center load as we're starting to understand it, and then also a few points about what's happening in California. The conversations that we've been having in the context of our forecasting work, so the Energy Commission does all the energy forecasting for the state of California, including the electric sector. So that's unique. Mostly that's done by utilities with oversight from PUCs across the country, but the Energy Commission is tasked with doing the forecasting and working with all of those entities to do so. So we've had a workshop or two about data centers in the last year or so, and there's some ongoing work at in a number of places across the state, universities and the like, as well as the agencies, to try to get a handle on data center load. And wanted to kind of set the stage a little bit. We think of data centers as doing, sort of populating, informing the large language models as sort of like the cranking through the state of the known universe, and just getting all that in the models, and then using all that information to do inference of many types. And so I think that's true. I guess what I think we're starting to understand is that the training of the LLMs, that is now and ongoing and will continue, but increasingly inference will become much more of the compute associated with AI, and will drive a lot of the data center kind of energy consumption and capacity needs. I think inference itself has a couple of categories. One is sort of general inference that is that emerges from, creates patterns and maybe over time does not have sort of a real time. It's not so real time. It sort of ends up being a sort of informational bank or a library. But that real time inference will really start to take off in the medium term. And I'm not sure I know what medium term means at this point because everything's moving so fast. But as usage deepens, as all the sectors of our economy understand how to use AI and do prompts and much deeper kind of pervasive use with a lot more compute behind it, in the like sort of 2 to 4 year range, that will become the sort of the main event, maybe like by 5 years. So I could be totally wrong there, but I think that's where the tenor of our conversation is going. Obviously things change in real time, and we're all learning as we go here because this technology sector is moving so fast. But I think it's helpful to think about sort of the LLMs and sort of near term now, and growing, but not maybe growing super fast, but then inference really taking over, and then real-time inference as everybody gets a robot in their house or whatever, that will become sort of more of driving the compute. That's sort of general, and feel free to shoot arrows at that one. I'd love to be wrong, but we're all kind of learning, so I think that's part of why we're here. So in California, as I said, we have talked about for the data center load growth in the context of the forecast. I think it's generally understood that the hyperscalers and the data center industry are putting in a lot of interconnection applications, even where maybe like there's multiple interconnection applications, in the hopes that some of those come through. And so some subset of those applications will be real, but many of them won't. So I think even understanding sort of how many data centers, how big and where, is a work in progress. And a lot of that's driven by the uncertainty around interconnection, which I'm sure our panelists will talk about. How much capacity is actually going to be needed and where, what balancing authorities in what states, in what parts of the country, or globally. And this is a really critical question because we have to figure out how to manage the build out of the infrastructure, the transmission, sub-transmission, the supply resources. And increasingly we're sort of hearing that hyperscalers are looking at how to co-locate resources and hoping that gets them around even, or at least helps them manage some of the conversations on siting and permitting at the state level, and procurement at the PUC, interconnection at the balancing authority and the PUCs. So I think those interconnection challenges, I think, are right front and center. In California, this is also in the context of our supply build out as we move from sort of traditional fossil, largely, at least, half-ish or so fossil resources, and now we're up to about 67, 2/3 or more is carbon free. But that transition is ongoing. And so we're building out a lot of renewables, a lot of storage, and all that entails, and the investment that entails, and making sure that we have interconnection headroom along the way in the right places of the grid for these large loads is also really important. We're building out in California tremendously rapidly. We've, in the last 6 years or so, we put 35 gigawatts of new supply. About roughly half of that is renewable generation. The other half is large scale battery storage onto the grid in California. So, that's a peak load of about statewide, maybe 60 gigawatts or so. So we've built out a lot of capacity, new supply, almost 100% renewables. And so managing the large data loads in that context, it adds another sort of degree of planning need. We are seeing that the utilities are being pretty proactive in, I think there's this idea, oh gosh, there's no capacity, there's no headroom anywhere. How are we going to locate all these big resources without massive new resources that are largely co-located, or at least, nearby on the grid? I think we're finding that there is actually more capacity in near the load centers, near the user, than maybe we had thought. PG&E has done some polling of their large customers, and I think they're finding that there are places in the urban centers even where there is the ability to connect to sub-transmission resources, maybe not massive like out in the desert kind of scale, but big scale, significant scale in the load pockets actually, and ability to accommodate customers potentially that want to interconnect in those places. So a lot of TBD still in terms of identifying the sort of the real capacity that's available for data centers in the various utility service territories, but I think there's a lot of potential there. So the title of this includes load flexibility. That's one of my main responsibilities at the Energy Commission. We're doing a lot to sort of unlock load flexibility, and that includes data centers. I think that's an area of massive need to make sure that all the new loads in the electrification, enterprise be good citizens of the grid. That absolutely includes data centers. To the extent that compute can scale, move around a little bit, be time sensitive, I think that would be very helpful to the grid. So, absolutely looking forward to those discussions. I also have to mention energy efficiency, lower power, lower voltage electronics that produce less heat. That is it's both good for the compute energy consumption and also good for the facilities where the compute's happening, lower AC needs and the like for data centers. So we've funded a lot of research over the years on that, different kinds of cooling techniques, et cetera, and the like, but a lot more to do there, especially with the scale that's coming. So I think the Energy Commission and the PUC, we're working closely together with the CAISO and in the context of the forecasting and transmission planning and procurement planning and supply planning, both on sort of the physical infrastructure and also the cost issues that the PUC largely oversees as the economic regulator. But this cross-jurisdictional coordination within states across the interconnections in the country. So Texas is obviously its own, but the Western and Eastern interconnections, there are multiple applications for interconnection by the same hyperscaler across jurisdictions. And so I think that highlights the need for these conversations across states to compare notes and to see what's happening, to sort of understand as much as we can which applications will move forward and which will not, and sort of work together to keep an eye on all that. So with that, I think I just wanted to set the stage a little bit and talk some about California, but with that, we'll pass it, I think on, it's Kim. Kim, are you going first?
Yes, I'm up next.
Great, well, thank you so much. All right, well, you have the baton.
Thank you.
Thanks a lot.
Hi, everybody. I am Kim Van Winkle. I'm an attorney that works in the Market Analysis Division at the PUC of Texas. I'm working on the rulemakings to implement Senate Bill 6, and that's primarily what I want to talk about today. So can you flip to the first slide, I guess? Just a little setup. As everyone reads in their news clips every single day, like a lot of other places, but maybe a little bit more so, Texas has become one of the top places for data centers, hyperscale data centers to locate. And ERCOT covers about 90% of Texas. So most everything I'm talking about today is just regarding ERCOT. You can see that we've got tremendous load growth projections that we are needing to address, and about 75% of that projected new load coming on is from data centers. The ERCOT queue represents a huge portion of the whole country's average electricity consumption for 2025. So as we'll talk about in a minute, some of what we're trying to do is identify in load forecasting which loads are most likely to come and when. I'd say that the legislature, policymakers work looking at the resource adequacy and system reliability issues that this load growth raises, and that's probably some of what led to this legislation getting adopted. Another factor might have been, it's notable that the Texas Reliability Entity, as part of their regional risk assessment this year, upgraded the risk of large load integration from unlikely moderate to likely major. And so those are some of the underlying issues. And can you go to the next slide? So the Texas legislature met starting in January of this year, and in June, the governor signed SB 6 into law, and we've been really busy scrambling to implement it as well and thoughtfully but quickly as we can, because of the importance of speed in this process to everyone. So I would say that the bill provides us with some new tools to address the issues I just mentioned. The first bullet point is in the statute. It's, I think it broadly reflects the policy goals that everyone's working on here in Texas. it's to support business development in the state while minimizing stranded infrastructure costs and maintaining system reliability. And you can see how that plays out when we talk about some of the specific provisions. The rest, 1, 2, 3, 4, 5, the 6 bullet points are the main pieces of the legislation. And we're doing rulemaking on several of these, which we'll talk about. So we're going to be identifying, establishing large load forecasting criteria to standardize the data that comes in from the TSP to improve the forecast. We're going to be adopting large load interconnection standards to help streamline the interconnection queue and also establish financial standards and other substantiation measures so that hopefully the most realistic loads are going to be more easily identified and addressed. Third, we have in the legislation net metering arrangements, which isn't going to be a new regulation for large loads that are going to locate behind new large loads are going to locate behind the meter of an existing generation resource that existed and served the grid as of September 1st of this year. And those are going to require commission approval to be implemented. The bill provides also for a new competitively procured reliability service to be developed and administered at ERCOT. And this next one got a lot of press attention. I think it requires new large loads starting next year to work with their utilities and install equipment or technology that will facilitate remote curtailment under certain circumstances. And lastly, we are doing a big study of the 4CP methodology for allocating transmission costs in ERCOT, and we need to conclude that process by the end of next year. Okay, next slide. So now we have a lot of rules underway. Like I said, the law was signed in June, and we created a new project, 58317, to the umbrella project for SB6 implementation. And in August 1st, we filed a staff roadmap, indicating which rules are going to be on which time frame for getting implemented, as an aspirational but public aspirational goal. And we started off everything on July 21st with a public workshop to get comments, feedback from stakeholders, the public, about many of the criteria in the legislation. I mean, it was a pretty open-ended opportunity to answer broad questions about how should this law be manifested in rules and or protocols or other actions. And that was sort of the broad scoping discussion. So large load forecasting criteria is one of the top priorities. We've already got a proposed rule published, and the first deadline for comments to come in is today. We're getting a lot of filings today, and we're hoping to have this, if everything goes smoothly, adopted by March, because it's important for transmission planning that we kind of front load the standardization of the large load forecasting. And of course, the purpose is to try to get, if there are phantom projects or projects that are pursuing duplicate sites or that they just don't have the financing, we'll hopefully identify that. So we're going to have to adopt a rule that addresses the types of financial commitments that the load should provide, what kinds of site control they have, disclosure of whether they've got a duplicate request that would delay or eliminate this one. And that's just a cite to the statutory provision in the rule project if you wanted to look it up. Okay, next slide, please. We're going to do rule on large load interconnection standards. Again, with the goal of facilitating energizing these loads, but would not at the expense of system reliability or potential stranded costs in transmission infrastructure. So the rule will ensure that large load customers contribute to the recovery of the cost to connect them. There will be some form of financial commitment. This statute mentions something specifically, but that's all still being developed. But there's a mandatory study fee, and there will probably be, it'll reflect some minimum kayak requirement or perhaps security on a $1 per megawatt basis. And the statute requires the loads to disclose if they have backup generation that can serve at least half of their load, and for the purpose of complying with the future protocol where ERCOT will be able to have them deploy their backup or curtail their load after all other market services except frequency response have been used. And in September, we issued some staff questions to get comments, input on some of these things, like what the financial commitments magnitude should be and what refundability provisions we might need. And we got feedback on that on October 10th, and we're going to use that. We are using that to develop a proposed rule, which will be adopted sometime next year. Next slide. So there's a provision in the new law in SB 6 that requires the commission to review and approve new net metering arrangements that would take existing generation facilities off the grid essentially and make them behind the meter to serve the new load. And ERCOT has 120 days to do their study, which includes both their transmission security impact analysis and a new resource adequacy impact analysis, and submit their recommendation to the commission, who then has 60 days to approve, deny, or impose conditions on the arrangement. And the statute includes some conditions that the commission could impose, including required curtailment or addressing stranded assets. And in the meantime, because there are projects underway that want to be addressed before the rule will be final, ERCOT has announced that they've got an interim process in place that tracks the proposed rule and certainly tracks the statutory requirements, and that's being used for now, just in terms of how they're handling the study requests and everything. Okay, next slide. The statute requires ERCOT to develop a new reliability service for large loads that aren't price sensitive and that are not already doing ancillary services. And this will be addressed sometime next year, but this is not as far as long as some of the other things. And it's still to be determined what part the commission rules would play as opposed to just a regular product developed through the ERCOT process, stakeholder process. And the next slide. Sorry. Yes, so this is the provision I mentioned earlier for remote curtailment equipment being required for loads that interconnect, certain large loads that interconnect next year. And protocols, communication protocols and whatnot are, I think, still to be addressed. Next. So the market analysis team that I work with, I'm a lawyer, but we have engineers and economists, and we also have a data analysis team, and they are all working together on the study of the 4CP methodology that is used in ERCOT for transmission cost allocation and has been for decades. And just today, we issued a public notice that a data request was sent out to the TDSPs. So to facilitate the study that we need to do in order to evaluate the 4CP method and look at other methods. And we've certainly looked at what other ISOs have done there. And we will be using the data to try to evaluate the actual impacts before a draft rule is recommended and goes through the whole rulemaking process. That'll all be next year. But the statute does require that we finish it by the end of next year. Okay, I think I have one more slide. Yeah, it's hard to provide any kind of recommendations or insights because we are still in the process of answering a lot of these questions. But some basic observations that I just personally made. I do think that the workshops and requests for comment on specific questions helps streamline the process so we aren't introducing concepts that we could have easily vetted with some information on the front end. So I think that's good. There's also been some private, or not private, but like not at the commission. Like I attended a large load symposium sponsored by UT, and they had a lot of stakeholders there, market participants, and experienced experts and policy people, and to just kind of brainstorm on SB6 implementation issues, but also just issues in the large load working group at ERCOT. And that paper is helpful ground level perspective of a lot of what's going on with data center curtailment issues and interconnection issues. So yeah, I mean, if you need to build in adders for the future on some, if you're setting a study fee, you could contemplate a more complex or expensive study fee might be needed, and you can inflation adjust or build in other adjustments so you don't have to redo the rule for that. Diverse types of large loads, traditional industrial loads sometimes are exhibiting different characteristics and creating different kinds of issues than data centers. And so always when we're implementing these things, we need to be mindful of the disparate impact. We don't want to deter investment in other sectors because we're trying to identify phantom data center loads, for example. And the last couple of things, just, yeah, I think about the load perspective, this perspective of all this from load, who's not got a lot of experience being directly regulated or involved in these level of discussions. And with data centers, sometimes that means there's also a layer of an owner or developer, and the end use customer is sometimes unknown at first and not involved. And then the last thing would be, yeah, like we have to think a lot about what's going on at ERCOT as well when we're developing the rules, because there's a lot of interplay between what's happening, and they have to work together in order to make sense. And that's all I have. Thank you.
So fascinating. Thanks, Kim. That's terrific. I imagine that may generate the level of detail is fantastic, and it's great to know the sort of status of everything. I imagine that'll have some questions later on. So hopefully, really appreciate that. So we'll pass it on to Jeff. Yep.
Okay.
Good. Let's see. You and Ben are going to sort of a tag team it.
We are indeed. Thank you.
All right, great. Take it away.
Yeah, appreciate it. Appreciate the chance to be here today to tell the story of Verus Data Centers. Quick intro. My name is Jeff Bladen. I'm head of energy at Verus. 28 years in the power industry. Most of my career, maybe a majority, spent in executive roles at PJM and MISO. About 5 years ago, I got into the data center world, leading global energy at Meta, and then about a year ago, joined Verus. And I do want to say a quick shout out, thank you to Jeff and NARUC for hosting those demand roundtables. I had the honor of participating in the demand roundtable that occurred at the Boston Summer Policy Forum that NARUC hosts each year. So it was a great conversation, Jeff, for what it's worth. So I'd encourage anybody that's interested to show up in Seattle and listen in on it. I won't be there, but I know it was a great conversation in Boston. So with that, I'll hand it off to Ben to do some intros and then walk us through telling the Verus story.
Thank you, Jeff. As you're talking, I'm just realizing that I'm not able to share my screen without restarting Zoom and permissions. So I'm going to ask you to present.
Give me just a moment and I will pull the slides up.
All right, and I will
And do your intro while I'm doing
do a
it.
quick intro. Hold on, let me just use something real quick. Real time. All right, so while Jeff is pulling that up, thank you, folks, for the opportunity. My name is Ben Wheeler. I lead our product development here at Verus. I've been in semiconductor manufacturing and data centers for about 25 years. My career has been on the infrastructure side and basically trying to squeeze as much productivity out of large industrial assets as possible. So the opportunity to be here at Verus and build a new kind of data center that is participatory with the grid and also much more efficient for customers and for hyperscalers is something we're all excited to work on. Go ahead, Jeff. So I will preface by saying there's a lot of detail in these slides. I'm not going to cover all of the detail, but it's here if anyone wants to go and look at some of the stuff that's a little bit more nuanced. I'll give sort of a high level overview of what we're walking through. So I mentioned Verus, where our goal is to build the world's most flexible and sustainable data centers. We're taking a new approach of sort of building the entire data center engineering from the ground up to deliver hyper efficiency and grid assets to where our data centers can act as a resource to the grid rather than just an off-taker of large amounts of gigawatts of capacity. Our company is we're about 2 years old, so we're a relative newcomer, but our team is made up of industry veterans that have built gigawatts of scale of capacity and for both hyperscalers, third-party data centers, folks from the energy industry, like Jeff. You can see a collection of companies sort of at the bottom there. And we have a financial backing from our holding company. Backer is called Sidewalk Infrastructure Partners. They're a holding company with LPs that are very interested in long-term sustainable infrastructure projects. So Ontario Teachers Pension Plan, Stepstone, Alphabet. Go ahead to the next slide. All right. And I just to back up one slide, just in case it wasn't clear. We are not a platform company. We are a full-scale builder, developer, operator of data centers. And so think of us the same way that you would think of a QTS or a Vantage. We build data centers, lease capacity to hyperscalers. Okay, so new type of data center company. What sets us apart? Yeah, we can start here. I think the other slide was basically the state of the industry. There's not enough power to go around. We need to be load flexible. I think everybody on the call here is probably familiar with some variation of that same slide at every conference or every talk to sort of set the stage. But what sets us apart is that we really, like I said, we're building data centers from the ground up, not just to focus on tenants, but we really believe that we are part of an ecosystem that's serving three different stakeholders. So our customers that are, who we're leasing data center capacity to, so it's hyperscalers and neo clouds or our large enterprise customers, the utilities that are in the area that we serve, and communities. Since this is a utility forum, we'll focus a bunch on utilities, but there's aspects on the customer side and the community side that are also relevant and interesting. So I'll touch on those also. So first off, for customers, the way that we've designed our data centers is, like I mentioned, for hyper efficiency to do more with every megawatt. So what that means is for a given utility interconnect that we get to build our data center, we can lease a certain amount of capacity to our customers. And we, through our design, which I'll get into in a minute, can enable our customers to pack in effectively a lot more IT equipment than a conventional data center design. And so that means that they get more productivity, out of a fixed amount of capacity, so they're effectively getting more bang for their buck for what they lease. And how do we do that? This is a little bit more detailed, but I'll give a little bit of an overview. If you look at the box on the left where it says theoretical max, that total box represents a utility interconnect. So the amount of energy that's totally possible to get out of the interconnect at a given data center site. There's a certain amount of overhead that's reserved for cooling that has to be reserved for the peak, hottest, most humid day of the year. But most of the year, it's not really used very, very much. And then the remaining is what is able to be leased to customers, right? So this is the total amount of nameplate capacity that customers meaning hyperscalers, Google, Facebook, Meta, whoever, to roll in IT equipment. Now, within that leased capacity, generally only about 45 to 70% of it is utilized because there's a lot of variability, a difference between applications for cloud versus AI training versus inference. But an industry average, about 45 to 70% of that leased capacity is used. And so there's some headroom that's kind of gone to waste there, and there's headroom that's gone to waste in the amount of provisioning for for cooling load on the IT equipment. So with the Verus design, what we're trying to do is to eliminate all of that headroom and to compress it so that we can lease more capacity to hyperscalers so that we can take advantage of more of that utility interconnect. And so based on our capabilities and our analysis compared to a conventional data center, you can see in that box, we can lease up to 20% more capacity for a given interconnect and enable our customers to utilize more of that container that we lease to them. So that can translate in up to a 50% increase of all of the energy possible out of the interconnect being converted into productive IT equipment. So relevant for the utility industry because that translates to a higher capacity factor and more of the actual energy being converted into IT. For the benefit to the grid, there's a few different things that we wanted to cover, mainly the first two here, but I'll just run through the different categories. So we've got firm demand response at megawatt scale. So our data centers are being built with large battery energy storage in lieu of diesel generators as our primary backup capacity. We can also augment and add diesel generators or other forms of backup power if our customers want, but we have large 4-hour dispatchable batteries for the entirety of the data center. That works to unlock on the customer southbound side, peak shaving and other things that enable our customers to use more capacity in the data center. But on the north side, on the utility facing side, that allows us to do large scale firm demand response that's asset backed based on the battery. So that's facility level demand response where we can cut the load of the data center up to 4 hours for 50 to 100% of the load
And Ben, if I could just jump in and add one thing, and it's an important distinction from what you were hearing a few minutes ago from our friend from California, is that this is not workload management. This is not taking activities in the data center offline. This is using the batteries and discharging them to keep productivity inside the data center while reducing stress on the grid. So it's really a win-win in that regard. And the asset backing is what allows us to do that.
Right. So it doesn't preclude the ability to do load shifting. Our customers, for example, on the inside of the data center can do load shifting or workload curtailment or move workloads to another location. But the obligation to do that is decoupled with our design because we're satisfying the demand response call from the utility through the battery system as the main interface. As we start to run the data center off the battery state of charge decreases. And then we in turn send a signal to our customers to tell them we're in the middle of a demand response event. And if they wish to do curtailment in order to help the effort, they can. That'll preserve the state of charge of the battery for longer. If they don't want to, then it's within the SLA agreement that we have for backup capacity. They'll just run with a little bit lower backup capacity of the battery.
The other key distinction is that at least so far, this form of asset-backed demand response using large batteries has shown massive megawatt scale, whereas workload management has tended to be much smaller at the margin reductions in demand for relatively short periods of time. And I know we're relatively low on time, so maybe we keep moving.
Yeah. There's a little bit more to that. This is basically what Jeff just mentioned, the difference between direct demand reduction on the workloads versus at the facility level. The other thing, kind of just to double down on what Jeff said, because we are using the batteries that is a measurable and dispatchable or measurable and verifiable asset for demand response, it's rather than a commercial agreement or an agreement to do workload modulation. What we found in working with a lot of the utilities that we're talking to is that there's a lot more sort of willingness to incorporate that up front in the interconnect study process as a flexible asset that can be used to offset, transmission upgrades or generation upgrades. There's a lot more confidence in an asset-backed resource than workload reduction agreements. There's also a benefit if we do this and we basically curtailing the load of the data center at the peaks. That there's the other benefit is that it helps with downward pressure on rates to customers. So we're effectively, this graph shows a load duration curve for typical utility. If we have the ability to turn ourselves off of the grid at the peak demand hours and then recharge the battery during off-peak hours. And so we're, for the scale of data centers is growing and becoming a non-negligible part of the grid. It has a meaningful impact on sort of helping to flatten out the load duration curve and helping to apply downward pressure on rates, especially if we can help to offset any need for infrastructure upgrades, either on transmission backbone lines or for generation. And then just real quick on the community side, I guess I mentioned we are focused on sustainability and being sort of a member of a community, in addition to helping with utility rate reduction. Because we are running off of batteries as our primary source of backup generation, lower noise and air pollution, lower NOx and SOx emissions. Our water, we focused on having low water consumption. We've got closed loop air chiller systems. It's not evaporative cooling. We do have a little bit of water to help chop the peaks off of some of the hottest days of the year, but it's minuscule compared to what a conventional evaporative cooling data center is. And then reduced remote load demand. That's just for general data center compared to a distribution center, for example. Data centers tend to not have a lot of traffic going in and out. It's just electricity going in and information and heat coming out. Yeah, so one of the things, I guess, germane to the utility industry is like I mentioned, we're a relatively new company. We're building our first data centers now. In parallel to building our first data centers, we have developed a digital twin 70 megawatt simulation model and a hardware in the loop testing model of our data center design at NREL on their campus in Golden, Colorado. We've been able to prove a lot of the utility-facing capabilities we talked about, demand response and being able to run primarily off of batteries in the event of a utility outage in that model. We've got some papers that have been written and some case studies that are referenced here if anyone wants to take a look. We're continuing to do more studies with NERC and some other in partnership with MISO and Xcel Energy on verifying that data centers can satisfy conditions that are required for things like demand response or N-0 contingency, like transmission relief and things like that. So if you want, just be on the lookout for more studies to kind of bring some data to some of the concerns that we've seen in the media about large loads and large load swings and the capability of being able to drop offline based on utility signals. Just a snapshot here. We've tried to model our product portfolio of the services that we can offer to the grid off of the NERC Reserve products. And so this is sort of a menu of options of the things that we can provide via demand response through the battery energy storage systems that are attached to our data centers. And I think that was it. I know we're running low on time. There's a
Fantastic.
snapshot of some of the leadership team at Veris. I think there's some contact info in the slide deck if that's going to be distributed also. If you have any other questions or about Veris or data centers in general or some of the nuances of large load, happy to follow up with any questions.
Fantastic. Thanks, Ben and Jeff. That was terrific. And no, I think we're on the same page with respect to work modulation versus actual hardware backup. And batteries are definitely a key part of the solution here. So really appreciate the innovation that you brought to the table. And I guess I'm going to ask one question for Kim really quick and one question for Ben and Jeff, and I'll just do them both. One I wanted to ask, I guess relevant for both potentially, but price sensitivity, like in California, I think part of the context here is that we're not thinking that, data centers that do not have a geographical necessity are probably not coming to California and other, higher cost electricity states as much as, sort of more close latency dependent kind of data centers. So I'm wondering about sort of how you think about price sensitivity. I mean, obviously a lot of data centers going to Texas because of low prices. So maybe sort of put that in a little bit of context. And then for Jeff and Ben, let's see, I guess I'm wondering if you could just talk about maybe some of, like, what are your most innovative customers doing? You said they have the option of modulating load or doing, going beyond or pushing more battery power into the grid versus keeping some of it or, modulating away so they can have more backup availability for longer, that kind of thing. So maybe price sensitivity and then sort of the cutting edge of innovation.
Yeah, I would just say that the new large load demand management service that SB6 creates, like I said, will exclude price sensitive loads and loads that are already participating in other ancillary services. And that will be implemented by having ERCOT identify loads that have exhibited that characteristic.
Oh,
And
interesting.
whether that ends up being all crypto miners or others, I don't know, but it's been an increasing operational necessity for ERCOT to identify which type of large load is at the end of a node or whatever. And so
Interesting.
my understanding is that that work is not complete, but that they will identify who's been operating in a price sensitive manner, and also they know who's
okay. So this is sort of day-to-day price sensitivity, not sort of a data center is going to locate in South Dakota because of cheap power. Like, so these are two different issues.
This is like loads that are self-curtailing
based on price. Okay, got it. That makes a lot of sense. Great.
In some window of time, yeah.
So maybe Veris, you could comment on that sort of where data centers are going and not going based on electricity price, electricity costs, and then also just sort of the innovation question.
Yeah, why don't I take the first one, Ben? You take the second. So you're right, Andrew, that for the most part, data centers are triangulating based on both price and proximity to where the services are being delivered. And that places that have much higher energy costs will tend to fall down on that list for services that are not absolutely critical to be proximate to some local need. For instance, most of the federal government services are being provided out of data centers in Northern Virginia or financial services out of Metro New York for a variety of reasons that have to do with proximity and latency. Some other services that are a little less latency sensitive can be less proximate, but they still need to be in places that have strong fiber and strong proximity to other sources of demand. So there's definitely a driver, cost driver. But going to places that are really remote for marginally cheaper energy generally doesn't pencil either. So you end up with this triangulation effect where you get data centers going to some degree where there's other data centers already.
Great, got it. Ben, any idea or any sort of thoughts about what the most innovative customers are doing and how they're sort of pushing you?
Yeah, I can kind of bridge those two questions a little bit on the sort of, like, I think on day-to-day operation perspective. For one of the benefits of having data centers with large battery energy storage deployed is not only can we use that to respond to utility obligations for demand response, you know, tariff agreements, but we can use it day to day if our customers want to. We can use it day to day for, you know, demand charge, time of use pricing arbitrage, or trying to minimize demand charges to help optimize, you know, energy pricing. That has nothing to do with the siting of it, but on a sort of day to day operation, we can help leverage the battery to minimize, you know, either time of use charging, demand charges, or carbon intensity, whatever their preferences are, customer.
Right.
In terms of what some of the most,
I just want to do a little time check. We're kind of pretty much out of time. Maybe Camille or the NARUC NASEO team, you can chime in and let us know if we need to shut it down, or if we can go over a couple minutes.
I think we can go over a couple of minutes. You guys keep going.
Great, awesome, thank you. And then can we answer the Q&A sort of ex post, or someone can work on that online? Not sure we're going to get to all these questions.
Yes.
Okay,
Yep.
great.
Thank you.
Terrific. Thanks a lot. Sorry, man. Go ahead.
The other innovation, I think you sort of teed it off, was on workload scheduling and flexibility. Most of the big hyperscalers have workload schedulers that they use to manage jobs already, and a lot of them have interruptibility kind of baked into that. So if you're running video transcoding or logging or things like that that aren't necessarily need to be real time, those are preemptible, and hyperscalers already have that to be able to schedule things internally. And so, but responding to external signals to be able to do that has proven to be sort of a challenge for a while.
That makes a lot of sense.
And so I think being able to integrate in a way that de-risks it a little bit for them by responding to the utility obligation, you know, at the facility level, and then basically leaving it up to them whether or not they want to participate in their workload scheduling with some, you know, time delay or like advance notice. And being able to have that integration where at the facility we could communicate to them for sort of an internal demand response call, you know, call and response is something, you know, that I think is a really, really great sort of marriage of that workload interrupt capability and the sort of new facility designs.
Fascinating. And it sounds like there's a lot more. You're going to learn a lot as you bring these things online, and I'm sure really push the envelope even more. I guess finally, maybe for both of you, I think, you know, what questions should state officials ask data center developers before development? So how should these projects kind of get vetted? Because there's a lot of interest in figuring out what application for interconnections are real, and sort of to kind of de-risk that whole process in terms of the planning that state agencies have to do. And tell utilities what to do, right? So any sort of suggestions about how the process could be managed more efficiently and effectively?
I think there's a couple things that we would suggest, and not surprisingly, we're interested in how state agencies are interfacing with the regulatory process and utilities in thinking about flexibility as a component of prioritizing interconnections. That grid, large loads that are going to be grid supportive, essentially assets to the grid, we think ought to be viewed in a different lens than assets that are not going to be supportive to the grid, that don't bring assets to the table. That right now, the way our process works is you sort of have one single queue and everybody gets in line. And if you need a ton of stuff built to support your load, and you're at the front of the line, it happens first. And then everybody else who maybe doesn't need that built waits behind and has to wait to bring their benefits to the grid, while the others are handled first. So we think that there ought to be something akin to a fast lane for assets that are going to be grid supportive, not too dissimilar to what's happening at the wholesale level with generation that is grid beneficial. So they can move fast, they can be dispatchable. We think the same thing can happen with loads. So states thinking about that would be really valuable.
That's really interesting. Kim, any perspective or any sort of ideas on that from the ERCOT perspective? I mean, I think your market's heavy, right? So it seems like that might even interface well with ancillary markets kind of approach.
I mean, other than the standards that we're developing for large load interconnection and large load forecasting, which are both designed to work together to get phantom load out of the queue and hopefully accelerate energization of the ones that are serious and that are ready. I mean, those are really important items. The other thing that came to mind when you asked this question is that as a state policymaker, even though your office might be solely in electricity regulation, when we start to look at substantiating loads in the queue, you start to wonder about or ask about things like permits. And so sometimes you'll see issues with air permits or issues surrounding water resources. And maybe those are traditionally very much siloed away from your usual area, but you probably need to be cognizant and aware of that stuff. And there's a good consortium at the University of Texas at Austin. Their acronym is COMPASS, and it's in the Bureau of Economic Geology, and they have an oil gas background. And so they are sort of doing research in a holistic way that looks at land, water, electricity, fiber optics, and labor. And I think even though that's not entirely in my wheelhouse, it's inevitably affects the load queue. So
yeah, that's fascinating. And we have a siting process that is in the context of sort of asking for exemptions by these new loads, where the often common proposal is to have diesel backup on site, and so that brings mostly air quality issues to the fore. And so we work with our agency to do sort of a CEQA, Environmental Quality Act process at the Energy Commission to consider all of those issues when we consider those applications for any largish, above 50 megawatt kind of behind the meter backup. So yeah, great comments, and I really appreciate answers to the questions. Camille, do we need to wrap, or do we have time to answer any public questions in the Q&A?
How about we go until 3:10 and then we'll go ahead and wrap up.
Okay, that sounds great. So I'm looking at the questions here in the, let's see, there's one in here which I'm not sure how relevant it is, but maybe you can tell me. It sounds interesting. Would the panelists want to offer perspectives, pros and cons about NERC's proposal to make large load data centers registered entities? Does that ring true at all?
Not super familiar with the proposal, but I can say I know what a registered entity is, and I guess I'd want to understand better what problem we're solving by having any kind of retail load register with NERC. Obviously, this is a whole brave new world right now, and we're trying to figure out how to security constrain the grid, but would need to be more familiar with the proposal.
Okay, that sounds reasonable. And I think maybe in the context of like actually being a resource that's relevant for the transmission level, if you're big large loads that have a high degree of flexibility, or at least some supply resources like batteries.
I think the issue is when you register as a generator or as a transmission asset, there's a whole bunch of benefits that actually come along with being a registered NERC asset. You have certain rights that go along with that don't seem applicable to the load side, and the result is that you'd end up with obligations but no rights. And so I'd want to understand better how you'd balance that.
Right. And then there's another question that actually echoes something I wanted to ask as well, is sort of, talked a lot about batteries as backup assets. Are there any other backup assets that we ought to be keeping an eye on in terms of what's coming?
Yeah, I mean, there's our solution, our data centers, we're building large scale, batteries. We have the ability to flex into other sources of power that can feed into our power plane and contribute towards the common power pool that the data center runs off. There's other data center developers that are focused on behind the meter generation. I mean, because of the situation with scarcity, I don't think there's many rocks that aren't being turned over to look for solutions. So there's a whole lot of different. I think if you can dream up a way to pump electrons into a data center, somebody's thinking about it.
And let me amplify on that question a little bit, because there was a question about batteries other than lithium ion chemistry. Are there considerations for other batteries, or are there concerns about performance and speed of cranking them up and so forth.
We've got folks talking about fuel cells, in the context of California's clean energy transition, right? Low carbon or no carbon resources are kind of front of the line.
Yeah.
I
On the
appreciate
lithium
that.
ion question, we are looking at different chemistries. Lithium iron phosphate right now is sort of for cost per watt hour, cost per watt is a really good sort of sweet spot of performance, safety, and cost. And so that's, you know, that's what we're designing our data centers with. That's not to say we can't go with sort of a complementary approach where maybe we've got 4 to 8 hours of lithium iron phosphate to handle the bulk of full backup of data center, but then longer duration, some other chemistry or some other form of storage for maybe the really mission critical workloads that's less than the full power of the data center, but maybe a customer or we'd want to extend the duration out to 24 hours or beyond. We'd have the capability to sort of play with the profile of backup generation and how long how long and how much power is provided by each.
And Kim, just to sort of wrap up the conversation, you mentioned reliability. Obviously, that's like job one for all of us is reliability. In terms of the backup question, how does that play in ERCOT?
All right, backup generation.
Yeah, just as a potentially
Yeah.
resource. It looks like the rulemaking that you're developing does
Yeah.
actually consider a lot of these issues directly.
Yeah, I mean, for the first time, ERCOT will be getting information about backup generation on site and with the ability to order its deployment or curtailment in certain situations. And yeah, I think there are discussions underway about what that means for telemetry at that site. And certainly there's open questions about duration and how that all is going to look to the grid operator. Yeah.
Great. I love the balancing, the low duration curve that you showed, Ben. It really does make very clear that we're talking about, a relatively small number of hours, but drawing a lot of load and how data centers can help smooth that out. So, level that out. So with that, I think we have to wrap up. We're a couple minutes even past the 1:10 deadline we had. So, or 1:10 on the Pacific time. So really, thanks so much, Kim and Ben and Jeff, for your insights and your expertise. Super exciting developments in the policy realm and in Texas, and also on just the technology front and the service provider front. As we face this brave new world of just massive data flows associated with AI and the rest of the digital economy that is just accelerating so quickly. And this policy, and those of us in the policy realm who are accountable to our elected officials and our ratepayers and everyone else in the state, it's just really comforting to know how much advancements are happening out there and to really learn from your expertise and what's happening across the country and beyond. So thanks, Kim and Jeff and Ben, really again, and pass the microphone back to Camille to wrap us up. Thanks a lot, everyone.
Thank you guys all so much for your time. Really appreciate it. And Andrew, thank you for doing an excellent job moderating. I will go ahead and stop the recording.